do is I'll take my point 1 and the length would be 1 to 8. What I have assumed is that the distance between 8 to 1 has already been wound on the string when it reaches 1, right? That's why I'll take 1 and 8 with my center as 1. I'll cut an arc on this line that will show me what, that this is the end point P which has remained. Then next what I'll do is I'll take point 2 up till point 8, the distance, then center here, and I'll cut an arc like this from 3 like this, 4 5 6 7, and finally I'll come back to 7. So I'll get what, I have 1 point here, 1 point on this, 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 and 1 point on this, and finally what will happen, I'll join everything to have my what, to have my involute. Let's move. So I've already explained you what we have to do. The distance that we have to take is 1 to P, as it is written here. P1 as center, cut an arc at P1. Then next 2 to P, cut an arc at this line, that is P2. Then 3 to P, then cut an arc here. Now you guys, when you are drawing it on the sketchbook, this line will go beyond because you don't know the exact line. Now why I have taken this point exactly, the lines, the tangents exactly of this line, because I had to accommodate this figure in this particular area that I have in my PPT. So that's why I've taken the length equal to your these lines will go beyond this, and then there will be an arc that you have to cut on this, so that the person who is checking the paper is clear that you have followed the steps to the point. So all these lines will come this way, and then what will happen is finally you will have these points. You have this P, you have P1, P2, P3, P4, P5, P6, P7 and P8 as I have on my screen. The next thing that I'll do is I will just join them by a smooth curve to give what, to I have an involute. Now this is a single convolution of the involute. Now if my length is, say this is my length, this is my length, this is my circumference. Now what happens is, now if I have the double of the circumference at both my hands, so what will happen, there will be, instead of being just one curve being stopping here, there will be one curve ending, then second curve will go on, and at the end of the second curve my the string length will get exhausted. So it depends on the you have to always, the length of the string that is given divided by the circumference of the circle will give you how many curves, or sorry, no, how many turns would be there in this involute. So that you have to make sure that the number of turns that you depart that is perfectly done. So this is the thing, and this is the involute that is being constructed. Now there can be different options, so there can be different variations in this involute. As I told, one of the variation would be like increasing the number of convolutions for this curve. That is, this is just one convolution, I can do it 3 4 5 6, as many as I can. So the more convolutions I have, the more complex the figure becomes. The figure looks complex, it does not actually, it is not actually complex for drawing. It is just complex in looking at it because there are a lot of wounds. But if you follow this step and you draw the tangents and then you start cutting one by one, you take the length and you start cutting the lines, it is actually very simple, because you will get all the points in sequence 1 2 3 4 5 6 7 8 9 10 up till whatever sequence up to n number that you can take. So if you are drawing the figure, then it might not seem very complex to you if you are looking at the figure. So just don't look at the figure and feel that it is complex and don't stop drawing it, or don't even try to draw it. Once you start, you will feel, yeah, it is very simple. This is what I felt when I did my engineering. The same thing, that I looked at the figures and I was afraid, oh, how am I going to draw this? But then when I first understood the question and then I basically started drawing it, then I thought that it is very simple, because the same steps I have to follow one by one again. So if you have studied locus perfectly, then all these points would be, all these curves would be just walk in a park for you, because it is so simple. Locus was difficult to visualize because the mechanism was moving, but here there is nothing. There is a circle, there is a string, so you have to mount the string on the circle and it's done. Now the second variation that can come is, instead of a circle, it can be what, it can be other cross sections. Polymers can be there. There can be a pentagon, there can be a hexagon, there can be different kinds of figures for which they may ask you to draw the involute. The procedure basically remains the same, it does not change a lot. So in that, instead of the circumference, the path length will count, instead of the circumference, what will count? The path length will count. So that is the point that you have to keep in mind, that in your exams these might be the variations that will be there, but the question the steps that will be there won't change a lot. There will be minute differences, as they were there in cycloidal curves also. Different curves having a few different steps will result into a final curve which is a bit different from what the other curves are. Okay, so we come to an end of involute. The next thing that we have is we have spirals. Spiral, now spiral, for visualizing a spiral you must visualize a firecracker, the chakri that we have in Diwali. Diwali is going to come, and maybe you might have already started lighting fireworks. So take a chakri and open, burn it, or say light it out. What will happen is that it will start rotating, and if you see that the sparks that are left will go in a circular manner, so that particular creates a spiral. So let's visualize and draw the spiral. Now these are there are very simple steps of drawing a spiral. So let's see what happens. We will say कि we take a distance PO is given at x. What we are going to do is draw a spiral. Any distance PO is given as x, and let us begin the construction by first taking PO as the center and drawing a circle. PO as the radius and O as the center, and drawing a circle. So this is what we are going to do is, we have taken the center as O, and then PO, that is equal to x, as the radius, and then we have drawn what? We have drawn a circle. The next thing that we are going to do is divide the circle into 8 equal parts, and then divide PO into 8 equal parts. 1 2 3 4 5 6 7. I've named it as 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, 6 dash, 7 dash, and P dash. And OP I've divided into 1 2 3 4 5 6 7 and 8. Now what I'm going to do is, now it's very simple. O would be the center. Take your compass, keep O as the center. First take the radius as O to 1. Draw an arc from 1 to 1 dash. Take the radius as O to 2. Cut an arc from 2 to 2 dash. From O to 3, cut an arc at 3 from 3 through 3 dash. Now this arc would be a whole arc like this. Now O4, then draw an arc for O4. O5, draw an arc till O5. For 6, draw an arc till 6. For 7, draw an arc till 7. So finally you have different curves or different arcs on the circle. Let's see. That's what it says in this particular step. So let's see. The two of the curves are already there. The rest of the curves are forming. So you can see that P1, P2, P3, P4, P5, P6, and finally you have here P7. So all these curves, as I said, O to 1, cut, make an arc till 1 dash, then 2 till 2 dash, 3 dash, 4 dash. So you have, now you already have what you have. Again, this is for one convolution only. So here you have all these points. If you join them, you'll have a simple Archimedean spiral like this. A simple spiral. This is what this. Now the difference is that the spiral will always end at the center, because the center point is there. So the generation of the spiral is something in this way. आप लोग चक्री जलाओगे, when you light a firework chakri, you will get to know that the center is always from where the sparks are thrown out. So this is something of that sort. So this is the end of spiral. So with this we actually come to the end of engineering curves. The different types of engineering curves that we encounter, the different methods of drawing with different constructions are there. We drew conics first. In that we discussed how conics basically form triangles, circles, ellipse, parabola, hyperbola, and these kind of figures. What is eccentricity, what is directrix, what is focus, what are different methods of then we discussed what are different methods of construction of ellipse, and in that we discussed different variations, oblong method, rectangle method, then parabola also, that we discussed all these kind of things. Then next we came to parabola and hyperbola. There also we discussed the different methods that are there, parallelogram methods, directrix and focus method, and we did that. Then today Today we started with cycloidal curves, then after cycloidal curves we did this involutes, and after involutes we did spirals. So this is the basic curriculum that you have for engineering curves. Now there is one question that I took up, that was there in the midterms also, and I took up, and it's a very interesting question of a parabola. So there are you have to draw this by two methods, that is, one is by rectangle method and one is by tangent method. So if you have already known the steps, so let's try to depict solve one example of a parabola. That is a very interesting example related to cricket. So I've taken up this example, so we're going to solve this example of engineering curves, that is basically a parabola. So first let us discuss the question. This is a very interesting question that is there. A ball is thrown from a boundary of a cricket ground, reaches the wicket keeper's gloves following a parabolic motion. Just imagine India Pakistan का मैच हो रहा है, and say Virat Kohli is running, and we have Virat Kohli picks up the ball and throws it to Dhoni, so, and he catches it. Now he catches it, and then let's see, the main point that I want you all to know in this question will come right up here. The maximum height achieved by the ball from the ground level is 31 meters. So it has given what is the maximum height from the ground that the ball attains. It attains a height of 31 meters. Okay, then what happens is the ball and the radial distance that from the boundary to the wicket keeper is 75 mm. What is he saying? That from the point where Virat Kohli throws the ball up till the Dhoni catching the ball, what is the distance? The distance is 75 meters. Then there is a point that is given that changes a lot of one of the figures in the question. Assuming the catching position of the ball as 1 meter above the ground, construct the path of the ball and use rectangle and tangent method. Now see, when this is just for visualization. When Virat Kohli is throwing the ball, or say you are there in his place and you are throwing the ball, what you do, you bend down, pick up the ball, and then pick it up and then throw it at shoulder level. This is the right way to throw the ball. Now basically from where you leave the ball, that is also say at an average height of 1 meter, and if I am a wicket keeper, if I am catching the ball, I will not catch it on the ground, I will catch it at some level from the ground. That is what is mentioned in the question as 1 meter. So what does it basically say? That the projection starts 1 meter above the ground, goes up till 31 meters, and then lands 1 meter above the ground in wicket keeper's gloves. Now if the ball had started from the ground and landed on the ground, my maximum height would be what? 31 meters. For the question, for calculating in the question, I would have taken the height as 31 meters. But here what is happening is that my initial point is 1 meter above the ground, because I cannot throw it from beneath the ground, so that it starts from the ground, and the wicket keeper is catching the ball in his gloves 1 meter above the ground. So this 31 would get converted to 30 for what? For drawing the parabola. If you understand, for drawing the parabola, we will have this point as 30. Now let's see, for this method we'll take the base height as 75 and axis height as 30. Now what are we going to do next? This 30 minus 1, this 1 meter is the 1 meter above that it catches, that is there. Okay, so I've drawn a rectangle. Now for not complicating the things, I've taken this as 75 meters and I've taken this as 30 meters. Now what will happen is, when you're drawing this SR would have another parallel line that is 1 meter below it, say S dash R dash, and the rectangle would be what? P to S dash R dash then Q, that is PS dash would be 31 meters. But for constructing a parabola, this would be the initial point and this would be the final point that would be there. So that would be, the rectangle would be extended 1 meter beyond, but I just wanted to show that it is how rectangle method is being implied in this particular figure. That's why I did not take 31 meters instead of 30 meters, but actually the triangle that you have to draw is 31 meters, and then start the parabola from 1 meter above, or say 1 unit above from whatever you are taking. So the next point, let us mark the point of the maximum height. Now here again, it is not mentioned in the question there where it will be. So we will take this as the point of maximum height as half of the distance. So what we'll do is we'll take the center of PQ and mark it as C, and again from the ground this is the this is the position of the maximum height attained, and this D will again go back to D dash, so that will again become that will become 31 meters. But actually from the point of projection to the point of landing, the maximum height can be calculated as as 30. Now following the same path, PS, QR, SD and DR are divided into 7 equal parts like this. I'll let it go. First the bottom part is getting divided, that is DS or SD, into 1 2 3 4 5 6 7. Then what will happen is the next part, DR, is getting divided into 1 2 3 4 5 6 and 7. Then what we'll do, the next thing again, PS is going to, is dividing itself into 1 to 7 parts. QR is dividing itself into 1 to 7 parts. There. Okay, now what next are we going to do? We are going to draw lines from C that will connect 1 on both sides of the vertical segment like this. C to 1, C to 2, first on the left hand side, C to 3 4 5 6 and 7. Then on the right hand side again 1 2 3 4 5 6 and 7. Now what we are going to do is from the base, that is 1, we are going to revolve lines that are there to cut C1 on both the sides like this, perpendicular lines. As you can see, this is the parabola. The different points on the parabola are getting constructed, and once they are constructed, I'll pass a simple curve to have my parabola completed. So I have my points from P1 to P7 and P1 dash to P7 dash or P dash 7. So what I'm going to do is I'm going to pass this through a smooth curve. So finally what we'll have, okay, where did I miss? I'll just show you. If I can just take an escape, if you can concentrate on the screen, I would show you how it is done. If you can show the screen, I'll show you that how this particular thing is done on PPT, and it is there, so you can concentrate on the PPT screen. I'll begin from here, I'll go till there, like this, like this,